Hello everyone. As you know, I have uploaded already two videos where we have discussed electric field and charges and all the derivations. Last video we have discussed about electric field and electric field lines, and today we are going to discuss a further part that is called as a electric flux. Electric flux. Electric flux is nothing but electric lines. Electric flux, in the name itself, it has a electric, where the electric lines are forces passing normally through the given surface. Electric lines, if given, take a surface, let it keep it a perpendicular to the to this plane. So the electric lines passing normally means perpendicular to the that surface. These lines are perpendicular to the this surface. So we can say that the electric field lines which are passing normally through the given surface, the number of electric lines passing normally through the given surface is called as a electric flux. So we can write the electric flux, it is denoted by delta phi. So delta phi is given in the form electric flux means it is a, in the definition itself has the number of electric field lines passing through a given surface area. Electric field lines, electric field is written in electric field E into delta S. It is a given area. Delta S is a given small area. So electric flux is equal to E into delta S. So we can also write that electric flux that is given by delta psi is equal to E into electric field into area into cos theta, where theta is, let me give, if these are the electric field lines, take any surface from this electric field line from, so this is little bit bend, so the normal to this surface will be perpendicular to this, so the line will be like this little bit. This is a perpendicular line to this surface. The angle between the normal to the surface, this is a normal line to the surface between the electric field lines. These are the electric field lines. The angle between those is that is theta. So how much angle it is bend out, that also comes in the electric flux, that is E into delta S cos theta. Del psi equal to E into delta S cos theta is the equation of the electric flux. We can also say that electric flux per unit area, that is delta S, at any point in an electric field, it is a measure of the electric intensity. You can say that delta S is this side, comes this side, and becomes, we can also find the electric field at electric intensity at any point using the flux if they have given. So these formulas are very important. So in the CET based questions also they can give two values and they can ask anything. So remember this all. So the total electric flux through the larger surface area is a summation through the larger surface area flux psi equal to summation of delta psi through the large area is given by summation of E into delta S cos theta. This is the larger area. So using this electric flux, we can also derive one more formula which is really helpful for our seat question. They will ask you, consider a cone, imaginary cone. Okay, anything. This is a cone. Consider a cone. Okay, let us consider a cone and let P and Q be 2 points at the distance. Let P and Q. This is P and this is Q. At a distance R1, this is R1 distance from the O, from the center, or from the vertex, you can say. Cone means you can say vertex. This is R1 and this is R2. Q is distance at R2 from O. Then where charge Q is kept, here we can keep a charge Q, where plus Q charge is kept. Okay, let delta S1 and delta S2 be the small surface areas. Delta S1, these are small surface area. This is a delta S1 and this is a one more surface area. We have taken the surface area of this cone, that is delta S2. Delta S2 is the surface area, small surface area around the point Q, perpendicular to the electric lines of forces. If these are electric lines of forces, then these are perpendicular. So using these, taking these points, we can derive that let E1, E2, let E1 and E2 be this derivation is not at all important for your theory purpose. For CET also derivation is not important. Lastly I will say one formula. Remember, note it down, that formula, and you can easily solve the CET questions. Let E1 and E2 be electric intensities are at P and Q. At P, even electric field lines are passing. At Q2, at Q, E2 electric field lines are passing at Q surfaces, at delta S2 surfaces. So we know that electric intensity, we have given here electric intensity is equal to electric flux by area. So we can write that electric intensity equal to, that is flux, electric flux upon area. So electric flux upon area. Electric flux is we have already defined here in the electric flux from the beginning. We have said that the electric flux is the number of electric lines of forces passing normally through a given surface. Number of electric field lines, let n be the number of here in this case, let n be the number of electric field lines passing through these surfaces, delta S1 and delta S2. So we can write that E1 is equal to number of electric flux means number of electric field lines passing through this P surfaces, delta S1 surfaces, that is given by n is both. In the both the surface, n number of electric field lines are passing. So n divided by the E1 at E1 delta S1, the P at P, the surface area we have taken as delta S1. Same electric field at point Q is given by number of electric field lines is same, divided by delta S2. So we can write that let us take an angle. This is a solid angle. Cone means it is a three-dimensional cone. We cannot say it is a triangle. Three-dimensional cone. It has a three-dimensionally. Here all it is all covered here. So you can take this as a solid angle. Solid angle means a three-dimensional angle. We can take a full solid angle means a three-dimensional angle. Here it is a cone three-dimensional angle. So it is a three-dimensional angle. We have seen in mathematics, that is the angle between here, if the distance is d and the angle is theta, and this curve has a formula, that is S is equal to d into theta, that is L into theta, take it as L. So yes, this is the length of the surface of this, we can measure L into theta. This formula we know that. So same formula we will apply to find this surface length or surface area, that is delta S1 is equal to the delta omega. This omega is the angle between this solid angle. So delta omega into length between them, that is R1 square. R1 square will take because here we have two curves, one curve and two curves. The surface one curve, two curves. So we'll take this R1 here and down R1 here. So R1 square. Same like delta S2 is equal to, angle is same, so delta omega and R2 square. So we can write that electric field is equal to N upon delta S1 is the, how we got this, you can say that S is equal to L theta. We have seen in mathematics spherical coordinates, all L into theta. So same we can write that delta omega into R1 square. So N divided by delta omega into R2 square. Let we divide these both equations, E1 by E2, then everything cancels, n omega cancel, and R2 comes up R2 square upon R1 square. So this is the formula of electric from the electric flux formula. We can electric flux formula we can define this derivation E1 by E2. So it may be question if they have given two electric fields, distance between the at a point due to charge 1 they have given one distance. If they are asked another distance, and they have given two electric fields at point PQ, then we can derive one more distance also, or if they have given two distances and electric field also, you can find out the electric field at one point. This is also main formula for the CET purpose on this lesson. Okay, E1 by E2 equal to R2 square upon R1 square. In general, you can write that E is inversely proportional to 1 upon R square due to a point charge. Due to a point charge, that is, electric field is inversely proportional to the distance between the point where the electric field is to be find out between the charge Q and where you want to find the electric field. If the distance is R, then that electric field here to find here at the point, that is inversely proportional to this distance square, R square. This is one of the important, so please note it down. You can take a screenshot or pause the video and you can make the notes. Okay, if you make the notes, then it is only it will be remember for you. You can be revise it once again. Okay, next electric flux formula. You know that psi equal to here it is there, psi equal to E into delta S cos theta, E into delta S cos theta. So where the electric flux is maximum, where the minimum will see. If theta changing the theta, making the adding some numerical values theta, we can get maximum and minimum electrical flux. When theta is equal to 0, let us take that theta is equal to 0 cos, we can write that equation, del psi is equal to E into delta S cos theta. When theta is equal to 0, cos 0 will be 1. So delta psi is equal to E into delta S, or E equal to delta psi upon delta S. Electric flux is maximum when the plane of the surface is normal to the direction of electric field, plane of the surface. So if you have plane of the surface means, let us take these are the electric field lines. Electric field lines, let us take the surface will be maximum, will be plane of surface is normal. Electric flux is maximum when the plane of the surface is normal to the direction of the electric field. So we can say that electric flux will be maximum. We can take surface like this. Sorry. We have to take a surface like this, horizontal. So the angle between them will be 0.